My name is Zach. My name is Zach Arcara. I'm the Assistant Director of Operations here at the center. And our speaker today is Austin Stone. He's a Customer Success Manager at Planet Labs. He has a background in agricultural remote sensing, and he has an excellent presentation for us today on Planet Labs. Just a brief word or two about the background. So we have an ongoing contract with Planet Labs, and so we have access to their data and system. And so that's how I got to know Austin. My role sort of is behind the scenes to help organize the funding and add additional users and things like that. And one goal of today's Geospatial Studio is to increase usage, get some additional engagement with the service, and make sure we're taking advantage of our access. So if you are affiliated in any way with the Marine, Earth, and Atmospheric Sciences Department or the Center for Geospatial Analytics and would like access to Planet Labs data, please reach out to me. I'll put my contact information in the chat, and it'll also be available on the CGA website. All right, and with that, I'll turn it over to Austin.
Awesome, thanks, Zach. I really appreciate that. So like Zach mentioned, my name is Austin Stone. I'm a Customer Success Manager at Planet. And I get the opportunity to work with all of our North American universities, which is awesome. So I get to be in this space where I get to learn about research and innovative use cases all across the country, and actually places all across the world. And it's a great space. This is how I got to know Zach, and I'm very thankful that you invited me out to speak with NCSU today. So throughout this presentation, I'm going to be going over a little bit about what Planet is, about our satellites, and about some various use cases. And then the second half of this presentation will be a demonstration on how to use our Planet Explorer web application, where you can access our data and preview it. So it'll be a good resource for you to learn. And so with that, we'll go ahead and get started. This is just some background for me. Like Zach mentioned, also, I do have an agricultural background in remote sensing. So if there's any ag folks out there, I'd be happy to help answer some questions or start some conversations after the presentation. You can always contact me at my email address, which is astone@planet.com. So if you have any additional questions that you'd like to reach out to me for, feel free to do so. All right. So wanted to show this really cool video real quick of a launch that happened last week with our new generation PlanetScope sensors. We launched 44 satellites on board a SpaceX Falcon 9 rocket, and this is just so exciting for the company and for me. This is, anytime I see a launch still, I really like to nerd out. It's such a cool an awesome moment to get to see how humans have been able to, have this revolutionary technology, and to be a part of it is pretty spectacular. So, don't need to start that video again. Let's go to the next slide. Here we go. And so that's just a really exciting way to kind of kick off this presentation, because last week we were able to launch 44 new satellites. Our constellation is it's the largest Earth imaging constellations orbiting Earth right now. And so Planet's mission is to image the entire world every day, which we're able to do with our giant constellation. And our goal for this data is to make changes visible, accessible, and actionable. And with daily imagery at a 3.7 meter spatial resolution, we are able to do so. And so this is a really revolutionary way to look back down at Earth compared to other Earth observing satellite observations that have been going on for 30 plus years. So we get to the chance to actually look at all these changes at a much higher rate. And so as I'm talking through this presentation, I want you all to start thinking about different ways that you could monitor Earth with daily imagery. So what changes would you want to see? And we'll dive through the rest of the presentation. And so I wanted to give some context as to what types of things you could actually see from daily change. This is an example where we're actually able to detect early illegal logging operations by being able to detect roads that develop overnight. So forest managers are able to actually monitor their land by looking at our imagery and being able to see new developments or different changes that have occurred. So this is a really spectacular use case. Additionally, for people who are interested in foreign affairs or intelligence and defense, our imagery offers the ability to see different changes on different fronts. So this is a really exciting way to be able to monitor global affairs. And finally, one that I really like is being able to detect your crops at a much higher rate than you could with other satellite imagery. So being able to look at your field on a daily basis and not having to actually go out into the field to see exactly how your field is performing, but maybe you're able to look at the satellite imagery and be able to make those decisions before having to actually go out there. It also helps you reallocate your resources appropriately to make sure you can maximize your crop yield. And this, the words on here actually say you can show early signs of disease, which is another great application. You know, a lot of crops experience some sort of stress. With satellite imagery, you'd be able to detect that early on. And here's a really exciting use case that happened recently with the Dixie fires out in California over the past year. As you can see this image, it kind of highlights, you see a little bit of green, but mostly a lot of brown and black. And so this is one of our PlanetScope base maps. And you're actually able to see the impact that this fire had. But of course, our imagery has multiple bands of information, so you'd be able to actually detect other things. So you can take the same image, put it in a false color image, and you can actually highlight some of the things that you weren't necessarily able to see as apparently in the true color image. So here you can really see the highlight of the vegetation, which is in red, but you can also see how much that vegetation is impacted by all of the brownish areas surrounding all of the red. And furthermore, you can take these bands and start to quantify and calculate these different indices. In this case, this is a burn area. We're actually able to quantify the amount of change occurring due to something like a wildfire. So this is a really exciting way to use satellite imagery. And those were just a few ways that satellite imagery can be implemented into the work that you're doing. But there are the options are limitless to use satellite imagery. There's so many different use cases that are out there. For instance, the recent volcano eruption, our satellite imagery, we're able to tell like how much the volcano changed over between December and now. We're actually, I know there was like a previous eruption that actually changed the shape of the island that we're able to see in our imagery before the larger eruption that now almost completely obliterated the island that volcano was on. But now we're able to actually go to the island just to the south, Tonga, where the civilization is, and we're actually able to see how that city was affected with all the ash coming in and the tidal wave that came with that, or tsunami that came with that. So all that to show is there's a lot of applications out there, and a lot are very timely. And with our satellite imagery, you'd be able to identify those. And speaking of satellites, I wanted to touch on the satellites that we currently have in orbit. So our first one being our Dove satellites that are equipped with the PlanetScope sensor. You'll hear me interchange Dove satellite and PlanetScope throughout this presentation, but just know that those are synonymous. With our successful launch last week, we now have over 200 of these satellites in orbit, which is outstanding. This will help us ensure that we're getting daily coverage, which is really exciting. But also, the new satellites have equipped our latest generation PlanetScope sensor, which allows us to get 8 bands, whereas in the past, we were only collecting 4 bands. And I'll dig into those in just a second. The second satellite that we have operating right now is our Skysat, which is our high resolution satellite that you can go out and task. So you would place an order to have this satellite go to a specific area and capture an image. The images are much smaller than the scenes that you would see in PlanetScope. The resolution is roughly 50 centimeters, which is much greater than the Dove satellites. So you'll get a higher spatial resolution image, a much crisper image if you're interested in looking at more detail. So a little bit more about the PlanetScope sensor. So this is an example of the image that you could see to the left here. The resolution allows you to see things like roads and buildings, and you can even see out in the shoreline right there where you can see all of those ships. So it's a high enough spatial resolution to detect smaller areas and be able to pick out specific objects. The spatial resolution on this is 3.7 meters. It says right here that they're equipped with RGB and NIR, but now, like I said, with our new generation PlanetScope sensors, we now have 8 bands. And to put that into comparison, here are the different generations of our PlanetScope sensors. And I'll start with Sentinel-2, which is the European Space Agency satellite. You'll notice that it has a bunch of bands all throughout the electromagnetic spectrum. So starting to the left, this is blue, red, and green over here with some bands in between. But I wanted to show you where our bands stack up. So our Dove Classic, which is our first generation sensor, not quite as standardized as Sentinel-2, but as our PlanetScope sensors have updated and improved, we've been able to get it much closer to that of Sentinel-2. So for some of our most recent generation satellites, where you're able to use cross resolution analyses, which I think is really beneficial if you're wanting to compare between Sentinel and our PlanetScope satellites. So that's a really unique benefit. But as you see, as time goes on, in 2020, last year is when we started launching those latest generation Superdubs sensors. We're becoming a lot closer to Sentinel-2s. So that's a really exciting thing going for us right now. The next thing is just a little bit more about our Skysat images. So right now, it's a 50 centimeter resampled product. So a lot of folks use this for visual purposes. We do have RGB and NIR bands on board. So you can do some multispectral analysis, but this is really good for things like object detection and things like that. I know a lot of people in like urban planning like this satellite because you can zoom in to that urban level and actually see change happening at a much finer resolution than you can with PlanetScope. Excellent. And then this is an awesome graphic to kind of show you what our satellites look like in orbit. So how do our satellites actually capture imagery of the Earth almost every day? Well, this is how we do it. We have over 200 of these satellites in orbit. We try to follow the sunlight, so it's in a sun synchronous orbit. So we're always able to capture images when the sun is shining on different areas across the Earth. And then with our Skysat sensors, they're also in a sun synchronous orbit, but they'll be in a different path than that of the PlanetScope. It looks a little chaotic, but rest assured, there's a lot of space in between all of these satellites. So we're able to capture almost the entire Earth every day with all of these satellites. This is another one of those videos where I have to pause it and then move forward. So now that you know a little bit more about the satellites, you've learned a little bit about the use cases. Here are the products that we offer at Planet. So our first being Planet Monitoring, which is essentially our PlanetScope scenes. So you can access the scenes individually. Every scene captured from our PlanetScope sensor, you should be able to have access to. They're not stitched together or mosaic together, so they're each seen individually. Our Planet base maps, however, we have monthly and quarterly base maps that we generate for the Earth. They're visual base maps, so they just have the RGB bands, but this is a mosaic and stitched together composited product. So it takes all the images from a month. We have an algorithm that finds the best pixel. I don't know the criteria for defining best pixel off the top of my head, but what they do is they're able to find the cloud-free pixels and combine those together for a monthly cloud-free mosaic. Of course, not the entire world is cloud-free. You get closer towards the equator, and sometimes you'll have some cloud interference there. But for the most part, we're able to get a monthly global mosaic, which is pretty amazing. We have the Planet tasking, which I talked about with our Skysat. And then we also have Planet analytics feeds. And these are, we use our base maps to run different models to actually create vector files and raster files that identify certain objects. So we have road detection, building detection, ship detection, things of that nature, where we're able to use our base maps or our PlanetScope scenes, go in and run the algorithm to actually identify these different objects. So that's a really cool feature. But with the NCSU license that you all have access to, the biggest products that you will be working with are the Planet Monitoring and the Planet base maps. And I'll show you a little bit more about those when I dive into the Planet Explorer demo right after this. So now that you know a little bit more about the products that we offer, how do you get a hold of those? So the first being Planet Explorer. Again, I'll be showing you a demonstration of this platform, but it's our online web interface where you're in, preview the images, search through our archive, and then place an order and download the imagery from there. We also have an API. So for those who are looking to download in bulk or implement Planet Imagery into a tool that they created, we have this option where you can write in Python and order a bunch of data in bulk. And then you can place that into any tools that you might be using that you created using any programming languages. So it's a really cool tool to use for automation and things of that nature. And we also have some integrations. So I know a lot of people in the remote sensing field, they use software like ArcGIS Pro and QGIS. Well, we have a plugin that you can install and activate on your GIS workspace, depending on which software you're using. And it'll essentially plug Planet Explorer, our online platform, directly into your GIS workspace. So this is a really cool tool. If you want to see, you can preview the imagery within ArcGIS Pro or QGIS, and you can have your other layers active previewing. So you're able to actually see how our imagery is interacting with the data that you're already working with. So that's a huge benefit. You can also place orders in the integration. So that's a great way to say, all right, I like this image, let's go ahead and place an order. And it'll order, it'll take a little while to get it all downloaded, but once it's there, you can just immediately put that into your workspace. Something that's not listed here that I should have listed here is we do have a delivery system to Google Earth Engine. And I know in the remote sensing community, Google Earth Engine is a very hot topic and a very commonly used API. I would encourage you to check out our documentation that we have on our website that shows you how to get your Earth Engine account connected to Planet data. It's a bit of a process, but essentially what you have to do is connect your, you have to create a Google Cloud project where you can actually send Planet data to, and then you connect your Google Cloud project with your Earth Engine account, and then you'll be able to access it as if it were an image collection in Earth Engine. So it's a really cool tool, and you'd have to use a little bit of our APIs to bulk order your imagery. That way you can run different time series analyses or any other classifications that you're doing in Earth Engine, but that option is available. And now, after all of that, I just ask you all, what would you do with daily imagery? Before, I was asking what could you do, but now that you know a little bit more about our imagery, I want to know what would you do with Planet Imagery. But with that, that kind of concludes my introduction to Planet. I know I'm speaking to a lot of students here, so I did want to plug this one last thing, which is that Planet does offer internships, and those will be going live on our website in early March, I believe March 1st. So be on the lookout for that if you're interested. If you have any questions about those, feel free to contact me, and I'll be happy to get the answers that you need. And with that, I do want to go ahead and open the floor for any questions before I jump into Planet Explorer. Let's see, I think we have a couple of things in chat. Let's see. I have a question from Peter. Is there a use case that would leverage this technology to be used by cities or counties to base property tax valuations, tax credits, or tax assessments based on the vegetation density on the property? So this wouldn't be a carbon use tax per se, but a carbon sink credit. That's actually a really interesting use case, and there's definitely an opportunity to do that here. What's really interesting actually is I'm working with some folks out of American University who are actually looking at urban vegetation, urban tree phenology in DC. So they actually have a lot of information about the trees that are tree species growing in DC, and they're able to actually track phenology, which I think is really cool. It's not directly tied to tax assessments or property valuations, but something like detecting urban vegetation is definitely a capability, and being able to quantify that and measure change over time would be a really great way to kind of see how you can evaluate those properties. So great question. Any others? And feel free to unmute yourself if you have a question. I'm happy to answer however I can. But if not, I can jump into Explore.
Austin, I got a quick question. The Superdubs, I guess I don't know what the lifespan of a satellite is. When would the Superdubs come fully online such that you could expect 8-band data everywhere?
Yeah, great question. So actually, since we did start launching our Superdubs last year, we do have some available 8-band imagery. Right now, it's not available through Planet Explorer, but you can access it through our APIs. So if you're interested in that, I can help you out with some of the API documentation and point you in the right direction to access the 8-band. I will say it's a limited availability data set right now. Obviously, you can filter it out and kind of see like how much 8-band data is in your area of interest. But once the new satellites that were launched last week become operational, it will definitely be more available than it is right now.
Great, thanks.
No problem. Any other questions? That was another good one. All right, well, I'll jump into Planet Explorer. And so like Zach mentioned, also, if you're interested in getting access, feel free to reach out to Zach and he'll get you all set up. And once you do get everything set up, this is where you'll be sent to. So it's planet.com/explore. And this is our, I wouldn't say it's our complete one-stop shop, but it's a place where you can go in and find everything that you need. We have other links attached here where you can follow and check out some of our other data sets, or not data sets, but our other applications. But once you get your account set up and you log in, this is the screen that you'll be seeing. So I actually placed one of a test account of mine into the NCSU account. So whatever you're seeing here is what you would see. So starting off, you kind of first notice that you're in a giant map. Kind of looks like Google Maps, zoomed all the way out. But it's an interactive map, so you can pan around, you can zoom in and out. I know since I'm streaming, it might be a little slow for you all, and sometimes it takes a minute to have the preview generate for me. But this is an image preview, so I do want to clarify that the images that you see that are previewing on Planet Explorer are not the highest quality image. So once you download the image, that's when you'll have the highest quality image. We just do that because it, for previewing purposes and processing purposes, it's not feasible for us to have our fully sized image on a preview. So what you're seeing are some JPEGs previewed on here, but you're able to actually see all the imagery that we have, which is really exciting. You'll also notice that there's imagery of almost the entire Earth, and that is our base map. So what you're seeing now is our global base map. It's our monthly base map. So I'd point your direction towards the bottom right here, and you'll notice that there's a big timeline that goes back and forth from, looks like 2022, the start of. We don't have our January base map yet, just because January hasn't completed, but it goes all the way back to a little while back, at least to 2017. But what we can do here is actually click on each of these months. I'll go to August, since I know that there'll be a big change here. I can click on that, and the new image preview will pop up, and you'll actually be able to see how the Earth is changing at a global scale, which is really eye-opening. You can really see, obviously, in August, summer months up in the Northern Hemisphere, as opposed to December, when there's a lot more snow. Obviously, the daylight plays a huge role in our ability to capture imagery at the poles. So you see a lot of missing information here. A lot of that's due to data availability with daylight. But yeah, I encourage you to check this out. It's really cool to go back and forth and see the seasonality that Earth experiences over the year. It's really cool. I mean, this is February of 2021, and you're seeing snow just covering in the northern US, and then you come to August and it's all gone. Let's click on that again. So that, I think that's a really cool way to actually look at global change just from a very rudimentary level. But let's say I wanted to zoom in and start looking at specific areas. And maybe I have a specific area I'm interested in. To do that, I would do is come over here to this bottom right option here. If you hover over it, it says draw or upload a geometry. So this is the first thing you need to do when starting the search for your data, is to identify your area of interest. So there's a lot of ways you can do this. You can, create a box yourself. You can zoom in. There we go. But if you wanted to do something smaller, so this is a point, and you just pick a point and zoom in. But also, if you have your own shape files, you can upload those here. So you just hit that little upload button. You plug in your shapefile that you're interested in, and you'll be able to access it that way. All right. And then the next thing I wanted to, I'll go ahead and delete this for previewing or for streaming purposes. What I'm going to do is create a much smaller area of interest, so that way things can load a little bit faster. But I'll zoom in here, since I know y'all are in Raleigh. I'll take this little square and create it around the city here. And there we go. Excellent. So once we do that, we create our area of interest. You'll notice that this left pane populates with a lot of imagery. And so what this is basically the archive of our PlanetScope imagery. One thing I did skip over was how to access our base maps, but I'll touch on that a little bit later. But you can download our base maps as well if you wanted to a specific area. Of course, a lot of these are visual base maps, so they're the RGB, but we do have select areas that do have surface reflectance for any type of multispectral analysis you want to perform over an area. We do have specific areas that we have access to those. So keep that in mind as well, but I'll touch on that in a little bit. So back to what we're seeing over here in the left pane. This is all of our imagery for this area over the past few days. So January 19th, this was yesterday. So we're able to actually upload imagery from the day prior, which is pretty amazing. So you're getting data at a very quick rate. Not only is it from yesterday, but we do typically see dates from every other day in the week. So that's really cool. So you have January 19th, 18th, 17th, 15th. I'd imagine the 16th, we probably didn't capture anything due to clouds. So that's one thing that we do have a slight issue with, is sometimes when things are really cloudy, it's hard for our system to georeference the image. So even though we've captured the image, it might not populate immediately into Explorer. So just keep that in mind as well. But we're able to see a bunch of images here. You're able to see, so this is a great image, 100% within the area I defined. And then you come down to the 17th. Clearly it was a little cloudy. Looks like the 17th and probably the 16th and the 15th. Looks like y'all had a bunch of clouds in the area. So obviously we're collecting the images with clouds, but there are a lot of image availability with cloud-free days, which is really exciting. All right. The next thing I wanted to talk about was our filtering options. So let's say I'm looking through here and I notice there's a lot of clouds, and let's just say I'm looking at somewhere really cloudy, and 90% of the images I'm seeing on this catalog right here are cloudy. Well, there is a way to go in to our filters and change things up a little bit. So I'll start from the top here. So up here, we start with the imagery type. So right now I have Skysat selected on. It's kind of default on, but you probably won't see any Skysat imagery. If you do see it, it'll probably say something like purchase required or something, just because the license only includes PlanetScope. So just keep that in mind if you do see that. But coming down to this medium resolution, we typically call PlanetScope medium to moderate spatial resolution, and that's solely because we have Skysat, which is a much higher spatial resolution. But you'll notice that there are several different options for PlanetScope scenes. For me, I like to do a lot of multispectral analysis, so I typically stick with 4-band PlanetScope scenes. But there's also this RapidEye archive that we have. So RapidEye is a retired satellite of ours. It no longer operates, but if you wanted access to RapidEye, it'd be available. I think it was retired in 2020, so anytime before 2020, you'd see some availability there. We also have some non-planet data sets. So this is actually really exciting for those who work with other satellite sensors like Sentinel and Landsat. You're actually able to look at Sentinel and Landsat scenes on Planet Explorer. You're also able to download those, which I think is a really cool benefit. So if you're wanting to see how these things, how these images interact with one another, sometimes it's really cool when there's 3 on the same day. So you have a PlanetScope image, you have a Sentinel image, and a Landsat image all on the same day. That's always really exciting. That happens. It's not common, but it happens every once in a while, and it's pretty cool. And you can sit and compare those. So I'll try to find one that I can show y'all. The next thing I wanted to talk about are these environmental conditions. So you have this area coverage. This is how much of the area is being covered in a single day. So this image in particular, I look at my box that I've created, and it looks like imagery is populating the entire box. So that's a 100%. So let's say this area is really important to me and I need 100% coverage from every image. I can set that threshold to 100% or however much I want. I just kind of leave it at the default because I like to see what else is out there, and I can make that decision on whether or not I want that image later. We have another filter option, cloud cover. So it goes from 0 to 100. So obviously this cloud is very cloudy and I might not be able to use it. So I can set that cloud filter to, let's say 0% to 30%. And that'll mitigate the amount of cloudy images that pop up in my search. We do have a lot of other options like ground sample distance, off-nadir angle, sun azimuth, and sun elevation. So for some folks who are looking for a little more consistency and more technical users, you can set those thresholds how you see fit. And then the last thing I really wanted to talk about was down here at the very bottom is this instrument filter. And so the question was asked about the 8-band imagery. So right now, 8-band imagery is not available through Explorer. However, fingers crossed, sometime in the near future, we'll be able to add this feature to Planet Explorer, so you'll be able to have access to it. But you are able to access it through our APIs. And if you do access it through our APIs, you'd be calling this psb.sd, which is our Superdubs sensor. And then we also have our dov-r sensor, which is ps2.sd, and our dov classic sensor. So if you remember, let me see if I can go back here to the presentation really quickly. I showed y'all this graph right here. And this is a comparison between all of our sensors. You can find all of this information on our website. I'll direct you in a little bit so you can see how these different sensors compare. Since I like working across different satellite images, I'm going to stick with just ps2.sd and PSB, so our dov-r and our Superdub. From here, I can apply those filters, and you'll notice that all of my images have changed quite a bit. So looks like we actually did get a cloudy image in our search here. So as you can tell, it's not 100% perfect, but it did get rid of a lot of those cloudy images that we experienced earlier. So let's go ahead and look at this image here. Well, actually, I just see this. So one of the cool things about our catalog is you can kind of get a little bit of information about each image before downloading it. But first thing being here, you can obviously you can tell what date it was collected. You can tell what product type it is. So this is 4-band PlanetScope. This is Sentinel-2. And then you have a little bit more information here, the pixel resolution, the area coverage, which this covers 79%. And things of that nature. You can also see how many items are in each collection. So I can actually click on this. So I notice that it has 5 here. I can click on this arrow to view details, and you'll notice that, let me zoom out so you can get a better look at this. You can actually see where at the scenes are being captured. So they're broken up by different satellites. So you can tell on this one day, we had 2 satellites collect images over Raleigh. First being satellite 1057, the other being 2457. So you can see that there are 4 scenes collected by 1057 and just 1 from 2457. You can click on this arrow and actually see where the scenes are overlapping and where they're coming from. And you can download whichever ones you want from here. You can also notice that this scene right here. So one thing to note is that you can look here at the metadata as well. So for each scene, you have a bit more information about the metadata. So this image was captured by our Superdub satellite here. And let me get out of this really quickly and come to this one. And you'll notice that this was our dov-r satellite. So they're collected by different satellite sensors within our constellation, but together they're able to capture area. And all the filters that you placed earlier that we messed around with, you can see more information about those as well as this little image thumbnail. Another interesting thing to note is that every scene has a unique ID. If you're using our APIs, this is an important thing to have. You can actually use our APIs to catalog a specific area and run through the archive, and you'll be able to generate each image ID. And then you'll have to call the image ID to submit the order. But if you wanted to do that manually, you can do that here. You can copy the scene. So it's a pretty easy process. Let's see. So let's say I'm really happy with all of this data. Because I have it highlighted here, you'll see down here at the bottom, there's this order scenes button. This is what I would press to start the order, but I'll also note that you can hold Shift and select multiple inputs here. So if you wanted to order more than one date at a time, you can do that. So I'd come down here to the order scene. You'll notice I'm offered two options here. One to order the data directly to your machine. The next being order the data to a hosted data folder. And I'll talk a little bit more about what that is in a little bit. But right now, I just want to download it locally because I want to bring this into the work that I'm doing, the GIS software that I'm using. And of course, this exact same process is available in our integrations as well. So if you're using ArcGIS or QGIS and you just want to run through our archive using that platform, you can do so. So I'll hit next here. The first thing I'll have to do is create an order name. I'll hit continue here. You'll notice I'm downloading two different image types. So what I'll have to do first is select each one, because I want to say what type of asset do I want to download. Do I want to download a surface reflectance product? Do I want to download a top of atmosphere reflectance product? Or do I want to download some of the raw data? I typically work with surface reflectance, so I'll just go ahead and download that. And then for our Sentinel imagery, you have access to RGB and top of atmosphere reflectance. So let's say I wanted to continue with that. That looks good. I'll hit continue. You'll be prompted next to see if you want to clip those items. So based off of the area of interest I created, you'd be able to clip those images. And so that will help save some quota, as well as get you just the imagery that you need. From there, I can hit order. I won't hit order for this, but if I did, you would come over here to this little scroll icon, and all of your orders that you've gone through will populate here, and you'll be able to see how much longer it's going to take for the queue, because once you place an order, it'll be put in a queue. Once the order has been received, you'll see a little button appear that will say download, and that will prompt you to download from our servers to your local machine. And from there, they're downloaded as TIFF files. So if you've worked with Landsat or Sentinel in the past, it'll be really easy to pick up our data and work with that there. Awesome. Now, I wanted to show you some additional features in Planet Explorer that you might find useful. So if I go back to my search, I noticed that there's January 18th, 2022 Sentinel and January 18th, 2022 4-band Planet Scope. So let me zoom in a little bit. It just takes a little while when I'm sharing my screen, but I can come over here to this right-hand tab, and you'll notice that there's a couple of different options here. The first being this Compare Imagery tab, which I find very fun to use sometimes. So I can compare things like Sentinel and Planet Scope, and actually be able to drag in between the two to see the differences between the two. Or maybe I have two different dates. Maybe one day is filled with snow, the other day is, the next day where the snow had melted. You can measure something like snow melt within a day. You can visualize that here. It's obviously taking a little while to load. There we go. So I can use this feature to compare between images, which I think is just a fun feature. And it's actually really interesting to compare this with Sentinel-2, just in this context. I'm looking at a very urban space. With the PlanetScope information or imagery, I'm able to actually detect or be able to see the shapes of the building. Not necessarily be able to count how many are on each block, but I have a really good idea of whether or not something's a building. With the Sentinel imagery, probably more useful for a landscape scale analysis. So when you zoom in, it's a little bit more pixelated, but if you're doing more landscape scale, it might be a little more beneficial there. So yeah, that's a really great tool to have. The next thing I wanted to talk about was, remember when we were ordering the scenes, I'll go back to it again. You're prompted with this, I want to order this data for hosted analysis in Explorer. So it actually looks like we can't do any of our Sentinel or any of the non-4-band PlanetScope data. So let me get back out of here real quick and just select 4-band PlanetScope. And I think the internet broke. Sorry about this. Maybe I can come over here and show you some examples. So luckily, there's some example imagery that we have in our hosted data, which is it's a really cool way to see what you're able to do with it. So if you come over here on the left-hand pane, there's this option here that says access your hosted data for analysis. If you were ordering and you ordered it to your hosted data, it would populate right here and you'd be able to search it. Right now, I'll just use the demo data. Let's see, I'll use this one for now. But what's cool about this is it'll take the information that you were searching. And if you come back over here to this image, you have these two different options. You have enhance imagery, which is the ability to just kind of change how it looks visually. There's no real information you can derive from here, except for just, kind of for visual purposes. The next thing you can do is perform different spectral indices, which I think is a really cool way to view the data. Unfortunately, in its current state, there's no way for you to download this information. So let's say I know I want to run NDVI over 10 different images and I only want to download the NDVI. Unfortunately, you can't do that with through Explorer. You'd have to download the data and run the NDVIs separately. But that being said, if you're interested in just more visual purposes, you can plug in the data here and calculate things like NDVI and our other indices that we have listed here. But you can go between each image and actually visualize how these have changed. So again, it's not a quantitative product, but it is something where you can see visual change. So if you wanted to show someone, this is a flooding example. If you wanted to show someone how an area flooded, the impact of it, you can calculate something like NDWI and be able to identify where the water is and how it changed over time. So that's a cool feature as well. All right, I see a couple of questions in the chat that I've probably missed for a little while, so I apologize for that. But let me run through this real quick. So first one is Planet Explorer cloud cover filter is image-based, correct? Are there plans to implement an AOI-based cloud cover filter? That's a really good question. So yeah, right now it is based off of the image metadata itself. So that image that you see that was cloudy that we had earlier on, it was probably just clouds in that one scene. So the total cloud coverage percentage in that scene was probably what our filter was set at. But I do believe there are some plans to kind of get a little more creative with that. But as for now, I don't think it's a near future thing. One thing we do actually have that you might find beneficial, if you want to take this information, like this imagery out and plug it into your workspace, one of the bands that comes with our data is our UDM2 band, which actually has, so how we generate the cloud coverage metrics we calculate that by running an algorithm that detects the clouds, and then that layer that we calculate is available for you to look at. So you can actually see where the clouds are. If you want to do any like cloud masking, that would be available to you in that UDM2 layer. So that's a really cool way to kind of get around that a little bit. But for right now, we don't have that implemented, but hopefully sometime in the future. And then I have one from Owen. Hey, Owen, it's good to see you again. He says, how well does RapidEye integrate with newer products for time series analysis? Are the bandwidth mappings close enough to more recent products to need minimal correction? This is a good question, and I don't have the complete answer to this. Unfortunately, I haven't had the chance to work with RapidEye all that much, but I will say there are folks who are able to integrate or to use interchangeably the PlanetScope and RapidEye. We're actually working on something really cool called Fusion, which is this normalized product between RapidEye, PlanetScope, Sentinel, Landsat. It's a really cool product. They take all the wavelengths and normalize it to have one interchangeable product. And so they'll pick an area and they'll just take every satellite image ever, just about that's a multispectral sensor. They'll dig down and they'll normalize it so that you have access to it's almost like a daily product too for like the last 5 years. So it's a really cool way to actually see all the satellite imagery in action. So I hope that kind of answered your question, but I don't have the best answer for that one. Did anyone else have any other questions? There's a couple of other features I can touch on real quick.
Hey, Austin, there was another question further up in the chat. What kind of flood inundation data is available, particularly at the urban scale?
Oh, okay, yeah. So good question. So Planet doesn't offer specifically flood level information, but I highly encourage you, if you're interested in like Google Earth Engine, you can look at their catalog, and I think they actually have some flood mapping available in there. It's a really cool way to kind of explore what other data is out there. But right now, Planet doesn't offer any flood specific data sets. But that being said, PlanetScope, because it has such a high temporal resolution, you'd be able to go in imagery and actually be able to quantify the changes of the flood. I know one thing that comes with floods is a lot of clouds, unfortunately. So sometimes there's a lot of clouds in the way, but you might be able to get a really good right before picture. And as soon as the clouds subside, a good after picture. And so with that high temporal resolution, you'd be able to go in and start to measure or quantify any types of those flooding changes. Thanks for catching that, John. Awesome. Any other questions? Let me show you one other quick thing. Let's say I'm going back to our search here. Let's say this is a search I want to look at quite a bit. You can actually save this search so you don't have to go in and create the file or the area of interest every time. You can save it. I'll just save this search right here. I'll just zoom out and go somewhere else, but I can come over here to my left-hand pane where it says access your saved searches. Click on that, and I can go ahead and click on that. And it'll take me right to where I was. It saves all the filters I had placed. It saves the time of interest. So it's a quick way to go in and access some previous searches. Okay, looks like we had another question. So if we need to download data for a very large AOI, there will be several overlapping cloud-free images during the same day. What is the best way to get around that? Great question. So from the Planet side, you'll end up downloading that data anyway. But from there, you'll probably have to do some compositing on your own end. The first thing I would recommend is the UDM2 layer that I was referencing earlier to have a mapped out cloud reference. So you have that data, you can mask that out, and then I'd go forth with the composite. from there. That way you're not mixing the cloud data with your two overlapping layers. But that's how I would get around that. But I did also want to touch, so for very large area AOIs, another thing you could do is access our base maps, which are, like I was mentioning earlier, they're monthly composited images. So they're taking, the 30 or so images that we have and finding that best pixel. So they're trying to neglect all the cloud pixels and find that that best pixel. Obviously, for more cloudy regions, it's a little tough. Sometimes there's clouds 30 days in a month. But for most of the globe, we're able to actually get a pretty clear pixel. So you can check out our base maps. Actually, now that I'm talking about base maps again, I do want to show you guys a couple of other applications that you have access to. One of those being Base Maps Viewer. So I can come over here, and it's just like Planet Explorer, and you can look at all the different base maps that you have access to. I mentioned earlier that there's different surface reflectance base maps that you'll have access to. We do not create global monthly base maps, but in some areas we do. So you can access those through here. But let's just say I want the monthly global. You can come in here, and it's very similar to that of Planet Explorer. I can just create my area. Now this is a large area. This would take forever to download, but you can create that area of interest, and it's going to take a while to load here, but once it does, you can download from there. Oh, but this says no quads available. I think maybe it's because my area is way too big. There might be a limit on how much you can do in Explorer or in Base Maps itself. You can also go in and use our APIs to order a lot of data in bulk, if that's what you're most interested in. So yeah, you can see from here, I'm able to download each quad individually. I immediately downloaded that. Whoops. So it'll immediately download, just a heads up. But yeah, I can do that from there. And yeah, that's a great way to get around some of the clouds. If you're not looking at a daily image, if you're okay with the composite image. Let me exit out of here. Another thing that we have access, or that you'll have access to, is Planet Stories. This is actually a really cool tool. For the students online, if you're ever giving a presentation, this is a really cool graphic to actually show the change. So let's say right now I need to search for a location. So we'll just go back to Raleigh for now. I want to go to Raleigh, North Carolina. That's where I want to go. So this is wanting me to have a specific address. Well, we'll just go somewhere in the United Kingdom. That sounds good. And you can set your time of interest. I'll just leave it as is, July to January. You can click next, and you'll be shown all of your all the available images here. I'll just select a few. Maybe I'll add in some clouds just so we can get some variation. And then I'll hit next, and it'll create a really cool time series, which is really useful for visual representation, especially if there's something really large occurring that's would require you to show changes over time. So this is a really cool way to visualize our data. And you can just finish and download the video yourself, and you can use it for a presentation or what other meetings you might have. Awesome. I do also want to point you towards, so if you did have access to tasking, you would just select this tasking dashboard. It'll allow you to go to our tasking dashboard mechanism. But the next thing I wanted to highlight was this developer center, which is one of our online resource areas. So you have access to a ton of information here. You can learn a little bit more about our APIs. You can learn more about our apps that we offer, so Planet Explorer, Planet Stories, Base Map Viewer, all the things that we just looked at. You can get a little more specifics with our Planet Scope and Skysat imagery. So let me click on this so you're able to actually see a little bit more of the specs on it. Yeah, and then other resources here. And also our integrations page. So if you wanted to plug in your into your GIS workspace, you can download, install the QGIS and ArcGIS platforms directly from our website. For Esri products, I know if you install it, it'll immediately populate on the taskbar, so it makes it really easy to find. But with QGIS, there's a plugins tab that you need to open up, and you'll have to activate the Planet Explorer plugin. So that's how you would find it in QGIS. And there's documentation on how to find all of this as well. Earth Engine, you can come here for folks I know who are interested in this. This is a how-to to get everything set up. Let me see, here's the setup guide. But there's a setup guide where you can walk through and get your Planet imagery into Earth Engine. And here's a video as well that I would encourage you to watch. Excellent. And yeah, so y'all have access to all of this. I'm really excited to learn about how y'all plan to use it. So it doesn't look like we have any other questions, but I have questions for y'all. Do you see any uses in the near future using Planet Scope or Planet Data for any of y'all's research or any class projects? And if you want to share, feel free. You can plug it into the chat too. I just like to know what folks are doing. I think it's really cool to kind of see all the different use cases. It's a really cool space to work in. Is there any other things you want me to do in Explorer while we're here? Are there any ag folks online? Well, awesome. Well, this is all I had for you all. I'm happy to stick around and help answer any questions if y'all have any. Again, you can contact me. I'll put my email address in the chat, so you can message me if you have any other questions. I get a question from Victor. Austin, can you share the first part of your presentation with us, perhaps in a PDF format? Yeah, no problem. I'll be able to send this out to everyone. I'll send it over to Zach, and Zach can share it with everyone. Yeah, no problem at all. I'll attach a few links in there as well to some of our resources that y'all might find useful. There's a lot of cool stuff going on at Planet that I think everyone will be interested in. So I'll be sharing all of that information with you all as well. And then if you want access to this data, again, reach out to Zach. Zach, thank you so much for organizing this and inviting me to speak at NCSU. I really appreciate it.
Austin, you are very welcome. And thank you again for the presentation. It was excellent. Let's, I guess, stick around for a few more minutes to see if any questions pop up. But other than that, thank you again.
Absolutely. Yeah, I'll be sticking around for a few more minutes. So if anyone has any questions, I'm happy to help answer.
If nothing else comes up, perhaps you could like, how does explain how the tasking works, and is that like additional cost? How do people arrange for that? How does that work?
Yeah. So it is an additional cost. So tasking is it's kind of one of the it's not something that we have an academic discount for, unfortunately. But the way that tasking works is basically you'd find an area that you'd be interested in. You'd walk through our tasking dashboard, which is very similar to Planet Explorer. You kind of create your area of interest. The biggest thing is your time of interest, because you're actively going out or sending this information to a satellite to then go capture the image. So the image itself, or what will happen is you'll place the order. Once the order is active, you can give it about depending on what you're looking at, a lot of folks give it about like a 2-week time frame to capture a specific area. The satellite will go over and make a bunch of passes. Sometimes there's a lot of clouds in the way. We're really good about not charging you for cloud covered images if it's not useful for you. So we'll go in and task the satellite again. And then once you get an image that works for you, we can run a surface reflectance algorithm on it, or correction on it. So that way you have a corrected image if you want to do any multi-spec analysis. If you're looking at certain types of changes, you can order multiple tasks. So you can go from, you can order different tasks for a specific area. So you can actually have that high resolution change analysis that you'd be looking for, or whatever phenomena you're trying to monitor. Another really cool thing about tasking is we have the ability to do stereo imaging, which is also a lot of folks want to generate some DEMs, and there's some really interesting work being done out of Texas A&M that's taking our stereo imagery, and they're actually able to detect vehicles, which is kind of insane. So being able to detect change in elevation based off of like if a vehicle's is parked somewhere, it's pretty amazing. I know they're working on a paper for that, so hopefully there'll be some more documentation and more verification on that. But that's something that's like the level of detail that you're getting with the Skysat information. So yeah, other than that, there's not too much about that. We have go ahead, Zach.
Oh, I was just going to ask if there was anything sort of on the horizon. It seems like you're making, adding additional resolution in terms of the bands. What else are you guys working on in terms of the next generation of satellites?
Yeah, so that's a great question. We have 2 in the works that we announced last year at our Planet Explore conference, which I highly encourage everyone to attend. It's a free to register conference every fall. I'll probably be sending some information about that conference to Zach when it comes time, but free to register. So I highly encourage some students to register for that. You can also participate in it. But at Planet Explore, we announced 2 new satellites that we're working on. One being an upgrade for our Skysat satellite. So a higher resolution. We don't have a number yet. We're still working out the kinks, but it's a proposed higher spatial resolution than Skysat, which a lot of people are really excited about. The other thing about that satellite is it'll have a higher revisit rate. So the ability to go out and task an image would be more guaranteed than it is right now. Right now, there's a lot of competition. And so with this new constellation, we're going to try to mitigate the impacts of competition, which will be a really big benefit. Another thing that we have is coming down the line is a partnership with Carbon Mapper. This is our Fidelity satellite. It'll be a hyperspectral satellite, and right now we don't have the number of bands that will be available, but it's safe to say over 100. And what this will allow us to do is detect things like carbon emissions, methane emissions, things of that nature. So we're taking a really big stance on air quality detection. So that'll be a really cool way to start monitoring a lot of carbon emissions across the globe. So those are the 2 big things coming down the line. Obviously, we'll be continuing to replenish our PlanetScope fleet, because that's kind of our workhorse right now. It's our version of Landsat for now. So we'll definitely be updating PlanetScope and trying to create that global archive for as long as we can. So yeah, that's what we have down in the works for now. Those will actually be launched at the end of this year. That's the proposed date. So as the year goes on, we'll have more information about those satellites. And then once they are launched, it'll take a couple months before the data is operational. So stay tuned. This time next year, we might be looking at hyperspectral data from space, which will be really exciting. Awesome.
Great.
Any other questions? Happy to stick around. I'm happy to have any sort of discussion. All right. Well, this was really fun. Thanks for inviting me, Zach. Maybe we can do it again in the near future.
Yeah, I think that would be certainly, if there's interest, we can definitely arrange that.
Awesome.
All
Well,
right, well, thank you again, and we've shared our contact information, and we'll have it on the center's website. And if you want to follow up, you know where to reach out.
awesome. Well, thank you so much, everyone.
Thanks, Austin. Very much.
See y'all later. Stay warm if the snow's coming.
Well, thanks, John.
Yeah, that was great.
Yeah, that was a good presentation. A lot of information. Hopefully, we'll get some more users.
Yeah, I mean, going into this, I didn't realize that NC State had like I guess a license for access to this. So that's amazing. Yeah. Well, thanks for helping arrange it too. Yep.
Yeah, no problem.
Take care and be safe out there.
All right. Talk to you later.
All right. Bye-bye.